everyone, we're looking at question number 4 of winter 2018 paper 215054. The question reads, a rock from space is traveling at high speed towards the earth. Complete the equation for the kinetic energy of an object traveling with speed v and state what any of the terms in the equation represent. Pretty simple. There's the formula for kinetic energy is 1 by 2 mv square, and since they've told us what v is, but they have said if you're using any other variable, you have to tell us what it means. So we will write where m is the mass of the object, where m is the mass of the object. Then you have the b part that says the mass of the rock is 0.6 kg. When it hits the earth, its average temperature increases by 25 degrees Celsius. The specific heat capacity is 560 joules per kilogram degree Celsius. Calculate the increase in the internal energy. Again, straightforward, you just have to write these values in the formula. That is Q equals mc delta theta. You have Q equals mc delta t. One thing I want you to know is whenever you have a change in temperature is always in degrees Celsius. You do not have to convert it into Kelvin because change is always in degrees Celsius. So again, you just have to plug in the values. We have to find Q. So mass is given to us as 0.6. C is given to us as 560 into change in temperature, that is given to us as 25, and when you multiply this you get an answer of 8.4 into 10 raised to the power 3 joules. 8.4 into 10 raised to the power 3 joules. Not 84, it's 8.4. 8.4 into 10 raised to the power 3 joules. Then you have the second part that says use the answer from B1. So we have to use this answer right here to determine the minimum possible speed of the rock when it hits the earth. Now there are two things. We have to use Q and we have to find the speed, and they've given us two formulas, so we have to somehow use these two formulas. That means initially when the object was moving, right? So when the object was moving, which is represented by 1 by 2 mv square, what is the speed when it hits the earth? And when it hits the earth, its average temperature increases by, so we have Q equals m, which is essentially Q. What this means is, this says use the answer from B1 to determine the minimum possible speed when it hits the earth. Two things. When we say minimum possible speed, obviously that is when you have the kinetic energy, it's moving, so that it has kinetic energy. And when it hits the earth, it says right here, when it hits the earth, its average temperature. So we have to know there is the certain speed at which there was this increase in internal energy. So again, simply just have to do, we have to find this speed. So I'll make this the subject of my equation, and I'll say v square equals 2q over m. You have the q, which is 2 into 8.4 10 raised to the power 3, 8.4 into 10 raised to the power 3, over mass, which is given to us as 0.6, and then you take the under root and you will be getting 167, and it says minimum, so you have to round it off to the minimum possible value. Moving towards the third part, suggest one reason why the speed determined in B2 is less than the actual speed of the rock when it hits the earth. Again, whenever they ask you as to why this certain thing was lesser as compared to the actual speed, that means If it's less, that means there was some loss. If there was some loss, you can just say when it hits the earth, so there was some energy loss to the ground. So I can say when it hits the earth, there may have been some energy lost to the ground, to the earth. That's simply it. Whenever there's a decrease, there's usually a decrease in the energy. So you can just say it was a decrease in the energy. There was some energy lost to the ground when it hits the earth. And this is it for the third part and for question number 4.